80% of organizations report encountering risky behavior from their AI agents, yet only 20% possess the governance measures required to stop them. Traditional generative AI operates within a read-only sandbox. You prompt it, it generates text, and the primary risk is receiving an incorrect or hallucinated answer. Agentic AI operates differently. These systems possess continuous operation, long-term memory, and most importantly, read-write access to enterprise APIs. We have to treat these agents as non-human identities. They operate using legitimate, service-level corporate credentials to execute tasks across your environment. Traditional cybersecurity architectures, like firewalls and role-based access control, rely on a single core assumption: a human being is initiating the action. Autonomous agents break this core assumption. They formulate plans and execute actions independently, operating entirely inside the trusted perimeter. To understand the implications, we will trace a single agentic transaction and examine the 7 critical vulnerabilities outlined by the OWASP Top 10 for Agentic Applications. When an autonomous system compromises your environment, it does not hack the firewall. It walks through the front door as an authorized digital insider. This circular flow diagram represents the Agentic Cognition Loop. An agent continuously cycles through, perceiving input, reasoning, and taking action. The first vulnerability is Indirect Prompt Injection. An attacker embeds a hidden instruction within a standard document, like a support ticket. As the agent processes it, its reasoning mechanism cannot separate the hidden malicious command from legitimate context. This hijacked reasoning leads directly to the second vulnerability, autonomous tool misuse. The agent moves from thinking to physical execution. Operating under the attacker's hidden instructions, the agent uses its authorized API access to execute commands, like retrieving the entire customer database. This is the confused deputy problem. The breach succeeds because the network layer sees a valid service credential and approves the action, entirely missing the semantic hijack that caused it. AI agents do not strictly follow static, pre-programmed rules. They dynamically generate logic and execute code at runtime to solve problems. This introduces the third risk, unsafe code execution. Because this code is generated on the fly inside live production workflows, it bypasses traditional static software security reviews entirely. If untrusted context influences the agent's logic generation, it will execute destructive scripts directly inside a highly trusted environment. This dynamic operation also creates the fourth vulnerability, data leakage and shadow data flows. A compromised agent tasked with organizing files can inadvertently summarize sensitive, personally identifiable information and route it through unauthorized external connections. Traditional data loss prevention tools struggle to detect these leaks because the agent constructs the data pathways ad hoc, bypassing established monitoring choke points. In an agentic architecture, passive inputs turn into executable behaviors. The boundary between a safe data file and a dangerous system instruction no longer exists. We are moving past stateless chat sessions. Modern agents possess persistent episodic and semantic memory, retaining knowledge across thousands of interactions. This creates the fifth vulnerability, memory poisoning. Security researchers refer to this as the sleeper agent scenario. An attacker injects a latent rule during a routine interaction. For example, they instruct the agent to route all future vendor payments to an external, attacker-controlled address. This malicious instruction sits dormant in the agent's long-term vector database for weeks, evading point-in-time anomaly detection because no immediate action is taken. A trigger event, like the arrival of a legitimate invoice weeks later, activates the poisoned memory. The agent recalls the malicious rule and executes the theft. Disparate AI agents to connect, communicate, and collaborate across a network. These interconnected frameworks expand the attack surface. They create invisible shadow dependencies, where the actions of one agent rely on the unverified outputs of another. This leads to the seventh and final risk, privilege creep and governance gaps within multi-agent swarms. An orchestration agent often holds the API keys for multiple downstream subagents. If that primary agent's memory is poisoned, the attacker gains control of the entire ecosystem. Memory poisoning combined with agent-to-agent communication turns a single isolated injected payload into a cascading, enterprise-wide compromise. Perimeter defense is no longer sufficient. Organizations must shift their focus to securing the agentic loop itself. Looking back at our Agentic Cognition Loop, we must overlay a thick governance enforcement layer surrounding the reasoning and action nodes. The first architectural solution is Semantic Access Control, guided by rigid digital job descriptions. The system must evaluate the specific intent of an action against an agent's defined business purpose. A valid network credential is not enough. The action itself must logically align with the agent's job. The second solution is Immutable Memory Auditing. Organizations must implement cryptographic audit trails for all long-term memory storage. If an agent goes rogue, security teams must be able to trace exactly when and how the memory poisoning occurred. This pairs with intelligent forgetting protocols, which automatically flush unverified, outdated, or decaying data from the system to prevent latent exploits. Securing an autonomous agent requires continuous auditing of its intent and its memory, rather than merely verifying its identity at login. This fingerprint scan illustrates our ultimate enforcement layer, identity governance explicitly tied to human authorization. This brings us to the third solution, human-in-the-loop checkpoints. Workflows must be structured carefully. The AI handles the massive coordination, data retrieval, and synthesis, while humans are required to handle high-risk judgment calls. Any autonomous action carrying a material blast radius requires a strict challenge and response approval process before execution is permitted. Agentic AI offers massive gains in operational efficiency. We capture that value when workflow orchestration relies on machines, but accountability remains strictly human.